Okay, chapter 8 starts on page 149. We're going to be discussing how to calculate oral solid doses. So oral medications most of the time come in solid forms. So we're going to be talking a lot about tablets and capsules in this chapter. We also have liquid forms that we're going to discuss later in the supplemental lecture. So such as solutions, syrups, suspensions, tinctures, all of these different types of dosage forms. Oral meds are going to be absorbed in the GI tract, usually in the small intestine. So we'll talk about some different types of tablets and capsules here in just a little bit that absorb differently. It's very important that we know how to calculate a dose as well as a dosage. We'll also discuss the difference between those. Before we, even begin to think about filling prescriptions, we definitely have to make sure that we have these calculations down first. So, very important vocabulary terms here. I would highlight, star this slide. Make sure that you know the difference between a dose and a dosage. So the dose is going to be the amount of medication that's given at one time, whereas a dosage is going to be basically the quantity that's going to be dispensed. So it's going to need to be the total amount of medication that's given to complete the entire prescription throughout the entire period of the prescription time. So I'll discuss that when we look at some examples here in just a bit. So some rules here. Most capsules should not be opened or divided. However, some are specifically made for that reason. Spansules are made to be opened and put into food, something like that, but generally, most capsules should not be opened. Scored tablets. So scored tablets are going to have basically a little groove down the center that makes it easy for us to break them in half. Anytime a tablet is scored, that means it can be cut in half. Generally, unscored tablets should not be divided, but that's not always the case. Just because something isn't always scored doesn't mean it can't be broken. Just make sure that we always verify with the pharmacist. We can also have what we call enteric coated tablets. So these are going to be special coated tablets that basically protect them from the acidic environment in our stomach. So that allows the drug to pass through the acidic environment. That way it can start to be absorbed in the small intestine. Buccal tablets, so that means between the cheek and gum. And then sublingual tablets, that means under the tongue. These two types of tablets, buccal and sublingual, we cannot just give the directions of, take one tablet. That is not specific enough for the patient. We would need to say, dissolve one tablet either between the cheek and gum or underneath the tongue as needed or as directed. So enteric coated, buccal, and sublingual tablets, as well as any extended or delayed release tablets or capsules, should not be crushed, divided, or chewed. So we really need to be specific in our directions for all of these types of tablets and or capsules. If a part of a tablet, if a half a tablet is the answer to a dose, make sure that dividing the tablet or cutting the tablet in half will not alter the action of the drug. So always make sure that that can be cut in half if we're talking about a tablet. Always verify your calculations and always verify the medication and strength before you even print your label. Before you even think about passing that on to the pharmacist, you need to be double checking, triple checking yourself every time that you fill a prescription in the pharmacy. So we are going to be using both ratio and proportion and dimensional analysis to solve for some doses in chapter 8. So I'm going to go through some examples here just a second. Um, just for some patient safety, always recheck all of your calculations. Always ask yourself if your answer makes sense. Like I said earlier, ask questions. It's better to ask than to make a med error. Check your labels 3 times when you're pulling those drugs. As we start to work with medications over time, you're going to pick up on what the average doses are for different medications. So if you ever see an order that, seems way off from what you're used to, ask the pharmacist. It never hurts to ask. Um, we just got to keep that patient safety at the forefront of everything that we do. All right, so I'm going to do number 2 on the pre-test here. We're on page 149. So here we have the dose that's being ordered is 60 milligrams. And what we have in stock are 20 milligram tablets. So I'm going to do this both with ratio and proportion and dimensional analysis. That way, whatever method you prefer, you can do as well. So ratio and proportion, start with what we know. Well, we know that what we have in stock are 20 milligram tablets. So in each tablet, there are 20 milligrams. We know that. Now set that equal to what we're trying to solve for. So we're trying to solve for the dose. We're trying to figure out how many tablets will give us 60 milligrams. So remember, always keep your units equal to each other if you're doing ratio and proportion. So 1 tablet, we're solving for tablets. Now, to solve for x, we're going to cross multiply. So in this case, I have 20 times x, which is 20x. Set that equal to 1 times 60, which is 60. Now to get x by itself, I need to divide by 20 here. Whatever I do to one side, I have to do to the other. So then x equals 3. So the answer is 3 tablets. Now, let's stop and see if that makes sense. Well, if 1 tablet that I have in stock is 20 milligrams, and I give somebody 3 of those, we would have 20, 40, 60 milligrams, which is what they are ordering for the dose here. So the answer is 3 tablets. Now, if you prefer dimensional analysis, remember dimensional analysis is multiplying fractions, okay? So always with dimensional analysis, start with the unit that we're looking for. So in this case, we want to know how many tablets will give us a dose. So we want to start with tablets, follow that with an equal sign, and then start with a fraction that keeps that unit on top. So once again, we know that 1 tablet has 20 milligrams. And then, so we want to end up with just tablets. So we want to cancel out the milligram unit. The way we do that is by multiplying by another fraction that has milligrams in the numerator. That way, these can cancel out. So the only thing left is our 60 milligrams, and that's just by itself. So we'll put that over 1. Milligrams will cancel out. Now we can solve. So 1 times 60 is 60. 20 times 1 is 20. 60 divided by 20 still equals 3. And I have my unit left over here. So 3 tablets. Okay, so number 4 is an example of a dose where it says 7.5 to 15 milligrams. So this is giving the patient or the nurse the option to either give 7.5 or 15, depending, in this case, usually on the level of pain. So in stock, we have 7.5 milligram tablets. So if they want to only give 7.5 milligrams, well, that would just be 1 tablet, okay? Now, if they want to give 15 milligrams, well, most of us can see that 7.5 is half of 15, so that would just be 2 tablets. Now, if you didn't see that, it's okay, we can still set that up. So we know that 1 tablet is 7.5, set that equal to x over 15. That's a 1, it looks like an H there, so 1 tablet. And then we can solve, so just cross multiply. So 7.5x equals 15. Gotta get x by itself, so we divide by 7.5, and x equals 2, or 2 tablets. So if you need to set it up, feel free. If you can look at these and just figure it out in your head, that's great. That's the goal. That's the end goal that I want you to be able to do once you are done with this class. But right now, if you need to, set these up. So our answer, 7.5 to 15, would be 1 to 2 tablets. All right, looking at number 12 here. Now this one's a little bit more difficult because our units are different here. So we have a dose that's being ordered. We want to have 324 milligrams. The stock that's available, we only have 5 grain tablets. So I'm pulling out my chart here. The question's asking about ferrous sulfate. So when we're looking at ferrous sulfate, we want to use 1 grain is 65 milligrams here, okay? So in this case, we know that 1 grain is 65 milligrams. And they are ordering 324 milligrams. So we can either convert this into grains, or we can convert 5 grains into milligrams. Either way, but we need to start with a conversion. So if we know that 1 grain is 65 milligrams, then let's go ahead and convert this grains to milligrams. So we want to know 5 grains is how many milligrams? So we can just cross multiply here. So 65 times 5, and then 1 times x. So we have 1x, and 65 times 5 is 325 milligrams. Anything times 1 or divided by 1 is still itself. So x is 325 milligrams. So what we've done is converted those 5 grains into 325 milligrams. So we know that what we have in stock are 325 milligram tablets. Now, that is just 1 milligram off from 324. I really think the book should have put 325, but regardless, we would not do, 0.999 of a tablet, so we would just say 1 tablet. That would give us an adequate dose there. Now, if you wanted to use dimensional analysis, that's perfectly fine. So remember, always start with the unit that we're looking for. So we were looking for tablets. Follow that with a fraction that keeps tablets on top. So we know that one of our tablets is 5 grains. Now we want to multiply that by something that has grains on top. Well, I have milligrams here, but I know my conversion factor, which was 1 grain of ferrous sulfate equals 65 milligrams. Now my grains will cancel out, but I still need to get rid of this milligram here. So to do that, I want to multiply by a fraction that keeps milligrams in the numerator now. And the only thing left is this 324. That's by itself, so I'll keep that over 1. And now my milligrams will cancel. I'm left with tablets here, which is what I want. So now we can solve. So 1 times 1 times 324 is just 324. 5 times 65 is 325. If we divide that, this is what I meant by you'll get that 0.996. So that rounds to basically just 1 tablet. We would not give, there's no way for us to give that fraction of a tablet. So just 1 tablet is our answer, just like we had solving with ratio and proportion. Okay, let's look at this last question here. I'm on page 161, number 12. So we have Lopressor, 100 milligrams by mouth twice a day today, then 50 milligrams by mouth twice a day. In stock, I have metoprolol 50 milligram tablets. So metoprolol is the generic name for Lopressor. So same drug here. Says, what is the total dosage to be given today? So we're not looking for the dose, we're looking for the dosage given today. So this says we need 100 milligrams twice a day. That's for today. And in stock, we have 50 milligram tablets. Well, if I want to give 100 milligrams at a time, that means I'm going to need 2 tablets, okay? Now, if you didn't see that, that's okay. Let me show you how we set that up. 1 tablet equals 50 milligrams. And we need 100 milligrams with each dose. So 100 equals 50x, just divide by 50. X equals 2 tablets. Now, this is our dose. That is what is given at one time, okay? This is saying what's the dosage to be given today. Well, if we're giving 2 tablets with each dose, and we're doing that 2 times a day, well, 2 tablets two times a day That's going to equal 4 tablets that day or today. So we need a total of 4 tablets, okay? But it says, what is the total dosage in milligrams? So how many milligrams do we need today? Well, we're giving 100 milligrams 2 times. So we're taking 100 milligrams 2 times a day. So we need 200 milligrams today. So we needed 200 milligrams. So how many tablets are needed per dose today? Well, we said our dose was 2 tablets. What is the total daily dosage to be given starting tomorrow in milligrams? So the daily dosage to be given starting tomorrow. So I guess we didn't need to solve for how many tablets given today. I apologize. I got ahead of myself there. So what's the total daily dosage to be given starting tomorrow? Well, tomorrow we're doing 50 milligrams twice a day. So if we're doing 50 milligrams 2 times a day, that would be 100 milligrams because 50 times 2 is 100. How many tablets are needed per dose starting tomorrow? Well, our dose is what's given at one time. So we just need 50 milligrams per dose, and each tablet that we have has 50 milligrams. So we would just need 1 tablet per dose. So make sure you understand the difference between a dose and a dosage. Like I said, sorry, I got a little ahead of myself here. It didn't even ask us how many tablets we would need today, but you get the idea. This is what we're going to be doing, throughout this week. And then next week, we're going to focus on more liquid medications as well. But I'm going to also cover that a little bit this week in the supplemental math lecture.